Good morning, good afternoon, good evening, everyone. Uh, Thank you very much for joining this session. I am Dr. Ganesh. So, I hold a PhD from National University of Singapore in cloud computing, and I have several years of experience in industry and academics. Handled different roles as a QA architect, technical support manager, professor, site reliability engineer, technology evangelist, etc. I have given talks and workshops in different conferences across US, Europe, Australia, and Asia. So I'm a Kathakali artist, and Kathakali is a traditional one Indian dance from one of the states in India, one of the southern states. And the pictures you see here are all myself in various costumes, portraying various characters. So with that small introduction, let's start. So let me give a disclaimer that this is a gentle introduction to SRE principles and practices. The references are mentioned at all slides as much as possible, and enjoy the pictures of different places I have been to and about Kathakali dance at different places in this presentation. And I also suggest that we'll have Q&A towards the end of the session to ensure coverage and continuity. And don't forget to give your valuable feedback through LoudSwarm. The link is over here, bit.ly/feedbackuge. I just got this shortened URL so that it is easy for you to remember and then potentially help you get the feedback. So please don't forget to give us your feedback. So what is the underlying problem that initiated the thought of a site reliability engineering? The underlying problem is that the dev teams want to release awesome new features to the masses and see them take off in a big way. And the ops team want to make sure those features don't break things. Historically, that caused a big power struggle. And the struggle is reliability versus agility. So what is reliability? Google says that reliability is the quality of being trustworthy or of performing consistently well. And knowing reliability, let me give you the definition of site reliability engineering, SRE. So SRE is a term coined by Ben Traynor, the founder of Google's SRE team. And when someone asked him what is SRE, the definition by himself is SRE is what you get when you treat operations as if it is a software problem. Or a more formal definition is discipline that incorporates aspects of software engineering and applies them to infrastructure and operational problems. And what are the main goals? The main goals are to create scalable and highly reliable software systems. So see, the importance of SRE is to make sure your software systems are reliable. And it originated to act as a bridge between development and operations. So by applying a software engineering mindset to system administration. So you can see that an SRE engineer, a typical site reliability engineer, will split their time between operations, on-call duties, and developing systems and software that help increase the reliability of your systems and performance. And SREs collaborate closely with product developers to ensure that the design solution responds to non-functional requirements such as availability, security, performance, and maintainability. And moreover, they also work with release engineers to ensure that the software delivery pipeline is as efficient as possible. So it removes the conjecture and debate over what we can be launched and when. And it gives you a mathematical formula for green or red lighting launches and dedicates a team of people with ops skills to continuously oversee the reliability of the product. Doesn't sound revolutionary yet? Okay, so much of the magic is in how it works. Now, before I proceed, I have to really mention the Bible, according to me, for SRE is these books given by Google. So if you go to this landing.google.com, SRE/books, you will see a few books. So there is a book, this is the first book is called the Site Reliability Engineering book, and the second one is called the Workbook. They are the real foundations of all the principles where I gain knowledge from, where I applied this knowledge in my work and things like that. So this is a must read. You have them available online. You can read them. If you want a physical book, you can also order through Amazon or wherever and get it. It's really nice. So the key principles for SRE, before telling that key principles, what is common for all tech companies? Definitely, I'm sure all of you will agree that the users are the most common elements. Whether you are Google search engine serving a billion active monthly users who interact with your service for free, or Microsoft with 180.2 billion revenue in 2019, building a technology product for any of them means serving people. And hence, very important aspects for these companies, any company who serve people is SLOs, SLAs, and SLAs. They are nothing but the promises we make to our users, the internal objectives that help us keep those promises, and the trackable measurements that tell us how we are doing. So the goal is to get everybody, the vendor, the client, everyone on the same page about your system performance. How often will your systems be available? Or what kind of promises are you making about speed and functionality? Okay. So with that introduction to site reliability engineering, the key principles that I'm going to discuss in today's session are the important metrics, toil elimination, embracing risk, some important processes and process requirements, and finally, some documents that are very important for an SRE. Okay, and it doesn't end here, but in a limited time frame, this is what I think the best that can cover to give you a good introduction to site reliability engineering. So let me start with the metrics that matter. The three most important metrics that we touch upon or that we often hear when we think about reliability is SLA, SLO, and SLI. The SLA or the service level agreement is the agreement that you make with your users, your customers. Yeah, I'm going to do this. If I cannot, this is what I will do in turn for you. And SLO, in your team, what are the objectives that you hit to meet the requirement? And finally, SLI, the real numbers on your performance. So what is the difference? SLI, what we have chosen to measure towards progress towards our goal. Latency of a request, for example. This is often what we measure through our monitoring systems. And SLO, stated objective of the SLI, what are we trying to accomplish? Say 99.5% of requests will be completed in 5 milliseconds. Finally, SLA, contract explicitly stated the consequences of failing to achieve your defined SLOs. If that SLO is not met, you get a refund, for example. So let's dig a little deeper into SLI. SLIs are the parameters which indicate the successful transactions we already said. So some examples are things like availability, uptime of the service, number of successful transactions or requests, consistency and durability of the data, and we can often term SLA as this formula, simple formula called good events over valid events times 100. So SLAs fall between 0 and 100%. 0 means nothing works and 100 means nothing is broken. And they also have a consistent format. Okay. So the consistency allows some tooling to be built commonly around SLIs. So having heard about SLI, the next question naturally is, what are different types of SLI? If I categorize the different types of request, it could be request response, data processing, or storage. Accordingly, I can define different types of SLIs. So let's take a few of them. Availability. So what is availability? The proportion of valid requests served successfully. Take a request response service like a web page request. So percentage of HTTP GET requests for a particular link in the URL that have 2, 3, and 4 XX status measured at the load balancer can give you the answer for availability for that particular web page. If I want to turn this specification into an implementation, I have to make two choices. Which of the requests the system serves are valid for the SLA because we said valid responses, and what makes a response successful. Okay. Another one is latency, the proportion of valid requests served faster than a threshold. For example, percentage of HTTP GET request on a particular page that sends their response within X millisecond, not this, the time I am specifying. My request should be served within a threshold, X millisecond at the load balancer. Now, again, turning the specification means which of the systems, which of the requests are valid, and what threshold differentiate between requests that are fast and slow. What is a valid value for X? Is it 10 milliseconds or 1 second or 1 minute or whatever based on the service? And quality, the proportion of valid requests served without degrading quality. So which of the requests are valid for SLI and how many of that are served within the response with a degraded quality. Okay, so there is a lot more to go through. I just gave you a glimpse of SLIs on request response, but there are, if at all you are dealing with a data processing system, you will be able to see freshness, how fresh the data is, or how much of the data is getting covered and how correct they are and things like that. So we won't go through each of them in the interest of time. Having learned about or known about SLI, the next step is SLO. SLO defines the acceptable downtime of the service. Things like durability of the disk should be 99.9%, availability of service should be 99.95%, etc., etc. So how does SLO help? SLO is the most important parameter, according to me, from my experience when you deal with reliability. So how SLOs help? For a product, if reliability is a feature, when do you prioritize it versus other features? SLO will help you answer. Development, how do you balance reliability, the risk to reliability from changing a system with the requirement to build new cool features for that system? This is what a development will get answer by looking at the SLO. And what operations will get from SLO? What is the right level of reliability for the system you support? A well thought out SLO can help business answer a lot of important questions. As I said before, how do we prioritize reliability versus other features? Can we release new features and risk breaking the system without significantly impacting the user experience? How do we weigh operational versus project work? Everything get answered with SLOs identified for your product. Characteristics of meaningful SLOs. So once you design an SLO, if it is meaningful, it should be user-centric. It should be specific concerning with your customer. Challenging, but not too challenging. Specific yet simple. shared sense of SLO ownership. And SLO ownership does not lie only with the site reliability engineer. It also is owned by the vendors or developers or other people who are owning that product, sharing the ownership of that product. Some best practices for SLOs selection: avoid 100% targets. Never target 100%. Any system, no matter how reliable they are, potentially I would say, except life-saving systems that are deal within hospitals, every system is going to have some number less than 100, at least 99.999 something. So there is a chance of failure at some time. So we should accommodate that. And base SLOs on current performance if you have nothing else. And try to group SLOs by user performance. That will help you defining your SLAs. Continuing, develop more than one target for some services. You see this example, 90% of get RPC calls will complete in less than 1 millisecond over 30-day window. And 99% of get RPC call will complete in less than 10 milliseconds over a rolling 30-day window. So thereby we are very smart and specific on how our targets are. Give some buffer and have a plan to iterate. So do not get stuck trying to make your first attempt perfect. Start with something, repeat, evaluate, collect data, and then modify until you see you are comfortable. SLOs can be achievable and aspirational. Achievable means you would have historical data. You can derive your SLOs from those historical SLA values versus aspirational SLOs. If you have no historical data, collaborate with your product team to develop a best guess about what will maintain user happiness. Determine a time window for measuring SLO. So if you remember my previous example, I say a rolling 30-day window. It could be a calendar window too. There are two types of SLO windows. One is a rolling 30-day or maybe a calendar window. One observation from all these SLO analysis is outages originate from two main sources: problems with the service itself and problems with services critical dependencies. Often we may miss some of the critical dependencies. So what is a critical dependency? It is that if it malfunctions, causes a corresponding malfunction in your service. Maybe you are concerning about a UI and the database behind it is a critical dependency, or the network path that connects your UI to the database is also a critical dependency. Another observation is the mathematics of availability. Availability is a function of the frequency and the duration of outages. So I can typically tell availability as the ratio of mean time to failure to the total, mean time to failure plus mean time to repair. So what is mean time to failure? The outage frequency. And what is mean time to repair? Once you have a problem, the customer experience a problem, until the problem is resolved, what is the time you spent rectifying it? So having seen these observations, let me give you an implication, the rule of extra 9. If you have a service which target 99.99% availability, your dependent service should, a critical dependencies or dependent service should be giving 99.999% availability, one extra 9. That is to ensure that you have sufficient sufficient amount of time that you can afford to correct the system. And the implication too, a service cannot be more available than its incident frequency multiplied by its detection and recovery time. Assume 3 complete outages per year happen to your service that last 20 minutes each, means 60 minutes of outage. Then you cannot say that that service will be 99.99% availability, because 99.99% availability will translate to not more than 53 minutes of downtime. And you already had 60-minute downtime. So we cannot promise what we cannot. Correct? So I told you about the critical dependencies. So you see here, there is a rule of extra 9. So assume there is a service in green color, and I have next level services in the red color or the pink color. So all the services in that pink color which depend on which are dependencies for my green service should give an extra 9 in the availability. And one more clarification. If you have one service dependent at multiple levels, here service A depends on B, service A also depends on C, and C also depends on B. This does not mean I have to consider B multiple times. I can consider it once enough because it's after all one critical service or dependency. Now, if you are interested in learning or reading about more about this, just search on Google the calculus of service availability, which talks very beautifully about the whole math and the nines, the rule of extra 9 behind your availability. Okay. So one liner on SLA. We said SLA is what is indicated by your system. SLO is what your team targets for. And SLA, it defines a penalty that service provider should pay in an event of service unavailability for predefined period of time. Now, okay. So with that, let me move on to a very interesting topic called error budget. SRE engineers verify the code quality of changes in the application by asking the development team to produce evidence via automated test failures. So there's a threshold for permissible minimum application downtime, and that threshold is known as error budget. If a downtime during any changes in the application is within that particular threshold or error budget, then the SRE team will say, yeah, we are good, we can make this change. If not, we will say, no, please go try to make these efficiencies to make sure you are within your error budget. And that is how error budget helps. So it tends to bring a balance between SRE and application development by mitigating risk. Okay. So the ultimate goal remains application reliability and scalability. Okay, so let's see a little bit on error budget. Suppose your system availability is 95% and your SLO threshold is 80%. Then error budget is nothing but 95 minus 80, 15%. Now that 15%, if you do a simple math, targets to 108 hours in a month, 30 days, and 324 hours in a quarter. Come on, guys. You will hardly see a system where you will see the SLO as 80% because 80 is very lenient. Potentially, we will see most of the enterprise applications will be at 99 point some nines, extra nines. So there is a cheat sheet. If you simply again Google, you will get the cheat sheet. So this is, I found this nice PDF, a cheat sheet that gives you given an uptime and the downtime per month will be what, and the downtime per year will be what. A lot of systems you will see will be 99.99% availability, which is like 52 to 53 minutes per year. And this is also called as 5 nines. 5 9 means how many nines are there in total with the 2 9s before the dot, and how many nines can come afterwards. Okay. So how does error budget help you? Do most of your errors happen when you are doing binary releases? Or do something to make releases less frequent or less error prone or lower impact when there is an error? Or are you seeing steady error spent coming from intermittent application failure? All this you can start deriving from your error budget. Or another example, major application failures where most of your service goes down for many minutes due to configuration pushes, excessive load, or queries of death. Okay, so you can derive lot of insights from looking at your error budget and understanding where you are spending your error budget. So if you would like to recollect the key metrics that we have seen are SLI, SLO, SLA, error budget, mean time to recover, mean time to failure, etc. There are much more, but these are the key metrics that you will see a typical SRE team. And then comes toil elimination. Another important aspect of an SRE is toil elimination. So what is toil? Toil is the kind of work tied to running a production service that tend to be manual, repetitive, automatable, tactical, devoid of enduring value, and that scales linearly as the service grows. Okay. So anything that you do manually, repetitively, many times, a month or a week or a day or a quarter, and which can potentially be automated but not automated, and you don't feel any value in doing that, is a toil. Now, what is not a toil? Toil is not just everything I don't like to do. For example, if you don't like attending stand up on every day 15 minutes, you cannot say that as a toil. So they are part of the whole ecosystem to move forward, right? So includes things like team meetings, talking to your HR once in a while, maybe setting your goals for the year and then reviewing it with your manager. If at all you feel any of some of them are boring, repetitive, and manual, come on, they can be called as overhead but not toil. So as I said, if you want to define toil, it is simple. Exclude overhead and then look at what is manual, repetitive, automatable, tactical, no enduring value, and order of n with service growth. So any all of these can be toil. Examples, maybe reviewing non-critical monitoring alerts, copying and pasting commands from a playbook, applying a database schema change, making some configuration change. Any of these can be toil. Okay. So, and then measuring the impact of the work. What type of a work was it? First, list that down. And what was the difficulty level? Is it an easy task to be done or is it a hard task to be done? Who did the work? Okay. Now, how do we start identifying toil? The best place to start identifying toil is our team itself. Have a survey uh, identified for your team. How happy you are with the quantity of time you spend on that particular toil. For example, get an answer. Averaging over the past 4 weeks, what fraction of time did you spend on toil? What are the top 3 sources of toil? Start listing down questions and get answers from your team. That will give you a good perspective. And then measure it. Regularly compute an estimate of how much time is being spent on various types of work. And look for patterns, trends in your work items, in your ticket surveys, maybe customer feedback surveys or on-call incident response, everything. And then have some reports generated to understand how much human time you spend on them. And you will be able to understand a lot of toil coming existing within your team. Eliminating toil. So automation is the key in eliminating toil, according to me, and even according to Google. If you have an SLO practice, use some of your error budget to automate away toil. Okay. And when your automation fails, do a postmortem, understand where it failed, fix it, and then move forward. So till now we have seen two important parameters. One is various metrics and another one is toil. In toil, we spoke about what is toil, what is not toil, how do we deal with toil, and how do we identify toil, and automation is the way to eliminate toil. And here comes the next most important aspect, which is risk. Unreliable systems can quickly erode users' confidence. So we want to reduce the chance of system failure. For example, if you are connecting to this particular meeting request and you're facing lot of issues, the call is getting broken multiple times in between, how sad you will be because you came out with lot of uh, inspiration and excitement to learn something or to share knowledge with your peers for networking, and having such uh, unreliability will cause you a lot of imbalance. Whereas a strong system where you feel like you are right there in the conference room, where you are able to interact with people, you are able to listen to the speaker just like the way you are able to listen when you are in the conference physically. That is a system which who has really thought of risk avoidance. So in SRE, we manage service reliability by managing risk. Okay. So how do we measure risk? Lot of things are lot of things are difficult to measure. Service failures can have different effects. Maybe a user will start tweeting in the Twitter, or Instagram picture will come, or a reputational impact, a newspaper write up, everything can come up, or indirect revenue loss. Some are measurable, but some are very hard to measure. So there are two techniques that I would say are popularly used for risk assessment. One is FMEA and the other one is analytical approach. You again deal with maths. So FMEA stands for failure mode and effects analysis. It's a methodology developed in 1950s, one of the earliest structured reliability improvement methods. And I would proudly say it is a very effective method even now for lowering possibility of failure to reduce risk. So what is FMEA? Failure modes are the ways in which process can fail. Effects are the ways in these failures can lead to waste or harmful outcomes. And the FMEA is designed to identify, prioritize, and limit these failure modes. When do you perform FMEA? There are several times at which it makes sense to perform FMEA. Maybe when you're designing a new product, or when you're planning or performing on existing process in a different way, or when you have a quality improvement goal for a specific process, or when you have need to understand and improve failures of a process, or sometime you might be onboarding a new product which is already being managed and developed by a development team, and now it is going to be under SRE. You want to do an FMEA before you take that on that product. To perform FMEA is quite straightforward. Create a spreadsheet and start typing things like which service you are looking for, what are the potential failure modes, effects, causes, current detection or prevention controls, and have two or three metrics. Typically, severity and occurrence are very important. Detection is important too. So have a scale, severity, a scale of say 1 to 5 or 1 to 10 or whatever that works for you. And then occurrence. So take historical data for last 1 year or 2 years. And then accordingly, you classify the occurrence to between 1 and 10 or 1 and 5 or whatever. And then create a risk priority number. A sample risk priority number could be a simple product of severity, occurrence, and detection. Now, this will help you identify some of the high risk items for your current service, and then start filling what actions do you want to recommend, who is responsible for making that action, and then what actions are taken and signed off to execute in the next release. Risk can also be analyzed through analytical approach. So estimated time to detect. How long does it take to detect a problem? The sooner we detect, the sooner we can fix. And the estimated time to repair, the amount of time required to repair a system and restore it to full functionality. We have seen it, MTTR. And estimated time of to failure, time that an item is expected to last in operation, the good time when it is working in the right behavior. Now, if you collect this data along with the percentage impact, how much impact that particular issue happened. By the way, this approach is recommended by Google. So the link is also here. Uh, so you can potentially download this spreadsheet and then start filling all your risk items for a service. Start entering these numbers, the 4 numbers, estimated time to detect, recovery, how much impact it has, and estimated time to failure. And you will see that incidents and bad minutes will be popped up automatically. And the sheet also has another sheet which will stack your issues automatically based on my bad minutes per year. Again, you just touch the blue colors here, the target availability. What availability would you like to target? It will give you the magic by showing various colored values, with green being uh, nothing to worry. Everything, all green items are well within acceptable risk. And then the yellows are, there is a risk, do you want to accept? And the reds are absolutely impossible given the time. So you see here, for example, 99.99 means 13 minutes per year, and the last item here is also 16 minutes, so I cannot even accommodate that, uh, and things like that. So, and then you can also start accepting some of the yellow color risks and thereby play around to understand what risk can I accommodate within my error budget. So this is a beautiful mathematical approach, analytical approach, in case you love numbers. Okay, so we have seen metrics, we have seen toil elimination, we have also seen an introduction to risk. Now, process requirements. I'm not going to talk about lot of processes here because there's a huge list out there. But let me brief about engagement model. One of the important, since you deal with multiple teams, how do you engage? The engagement model can be, how do you engage with your development team? How do you engage with your customers? How do you engage with your vendors? Do you have a process in place? How do you raise a ticket with your vendor if you face a problem? And what are the SLO or SLA between you and your vendor? Everything comes into place. I'm going to talk about a special engagement system called PRR, Product Readiness Review. This is another engagement model that needs to be in place when you are engaging to have a new product to come under your SRE roof. So you can see PRR is all about understanding how your system works, the how much capacity to plan, what performance are important for your team, how do you respond in emergency. Everything comes under the product readiness review. So the objectives are verify that a service meets accepted standards of production setup and operational readiness. The owners are prepared to work with SRE and take advantage of SRE and expertise. Typical steps involve understand, analyze the product, analyze the service better, and then start understanding what improvements are required, and then give that feedback to the service original developers so that they can do refactoring. and then training the SRE team, onboarding the SRE team, and then improve it continuously. Okay, another process improvement is, or another process, important process when you deal with SREs, distributed monitoring or simply monitoring. Why do you want to monitor, by the way? To analyze long-term trends, to comparing times and iterations, building dashboards, conducting ad hoc retrospective analysis, alerting, yeah, a lot of users. I am sure all of you will agree that monitoring is very important for any large infrastructure, for any system. But we have to ensure that we have set reasonable expectations for monitoring. Simpler and faster monitoring systems with better tools for post hoc analysis to keep noise low and signal high. The elements of your monitoring system that direct to a pager need to be very simple and robust. Things like that. There are two types of monitoring, whether you are doing a black box monitoring or white box monitoring. So black box monitoring, for example, is a simple ping or HTTP, versus a white box monitoring is you are taking some specific internal logs and metrics and analyzing and then deriving insights. According to Google, four golden signals for monitoring are latency, traffic, errors, and saturation. So latency is the time it takes for a service. Uh, Traffic is how much demand is being placed in your system. The rates of requests that fail either explicitly or implicitly is errors, and how full your service is. Okay. So the last topic that I want to discuss before we wind up is docs that matter. So again, there's a beautiful article in ACM called Why SRE Documents Matter. It's written by the document developers of Google SRE team. You can search even by the title, Why SRE Documents Matter, SCM, to get this document. And they say very detailed analysis on the importance of documents for an SRE. So why is it important? What do you think? In the early stages of an SRE team's existence, highly skilled individuals are going to work on your team infrastructure. They preserve important operational concepts and principles, which are nuggets of tribal knowledge that are passed on verbally to others. If these concepts and principles are not documented anywhere, what will happen? We need to often relearn painfully through trial and error. And if it is allowed to continue, things will be fragmented, tend to degenerate as the team scales up to handle new challenges. Things will go wrong. Forgetting things can cause a lot of chaos. So I know you will agree that documents are very important. Now we classify different types of documents and for different types of SRE work. If it is a new service onboarding, for example, the PRR that we spoke about before, product readiness review, you should have a template for that and a process doc for new service onboarding, some service overview documents, engagement model document, etc. should be there. A PRR template may look like this: some architecture and dependencies, capacity planning, what are the risks associated through failure modes, process and automation, what are the other external services that your system is depending on. Have a PRR template very comprehensive so that you can collect as much information as you want to assess the risk, to understand the service better before you take ownership of that particular product. Similarly, engagement model doc says about when an SLO negotiation process, how do you deal with that? A new launch criteria and freeze policy and things like that. You can have a set of documents for running a service, including a service overview, a playbook for the service, post-mortem documents. So post-mortem template will include things like timeline, description of user impact, root causes, action items, etc. Policies and SLA, technical policies can apply. So you can have a bunch of policies that are defined. SLA we already spoke about. Documents for production products. SRE team is often required to spend 50% of their time on project work. So you should have a lot of documents created for a product that is in production. So maybe a about page, an API reference, code labs with contains sample codes, how-to guides, etc., etc. Uh, and documents for reporting service state is important, like things like quarterly service review, production best practices review, and things like that. And then documents for running SRE teams. Maybe a team site and a team charter, where an external customer or a service customer can go and look for whom to contact for a particular issue, things like that. And don't forget, our team will scale. We need training materials, checklist, role playing training drills, repositories with sample codes and sample notes for new SRE onboarding. And finally, every service lifecycle will also involve a eventual decommissioning. So you need documentation for how to announce decommissioning, and a process in place to update your document pages to remove that service references, and FAQ pages for that particular project and things like that. So documents are very important too. Okay, so final notes before I wind up to give you some time for Q&A. Summary in a nutshell, metrics are very important, but my take is start slow. Don't consider, or maybe you can list out exhaustive set of metrics, but start with only a few of them which you think are very important. Have your stakeholders or co-owners agree with what you have chosen, and then make sure they are all monitored and dashboards are available, and then start adding more to list as you review them periodically. For elimination of toil should be always on top of your mind. Identify toil. Whenever you see there's a toil, go and create a user story. Put it in your backlog saying, I want to avoid this toil. This is my plan, or this is what my thoughts are, and then start eliminating them. Then engagement models, things like PRR model and other engagement models. Risk assessment for your services, very important. Choose the right risk assessment method that you think is good for your service, and make sure approvals are obtained from, once you assess risk, approvals are obtained from your owners, and documentation is very important. And there are more services that I did not explain today than what I explained today. Things like blameless postmortem culture, release management, emergency response, the design principle behind SRE, which is NALSD, non-abstract large scale, large system design, testing for reliability, etc., etc. There is a huge list out. I strongly recommend you to please go through Google SRE books and workbooks in case you are interested in knowing more about SRE. And I have a playlist in my YouTube. Uh, okay, I think I did not mention my YouTube channel link here. Probably I will put it in our room Slack channel in case you are interested. I have a playlist for SRE, a playlist for machine learning, a playlist for game theory, etc. in my YouTube channel. And I try to add a new video every week or every other week. Uh, I think now we can be open for the Q&A for a short time. You can always shoot your question answers to my email addresses mentioned here, or you can connect to me via LinkedIn or ask me questions there, or you could potentially throw questions through our Slack channels created for this particular talk in the room 4. With that, let me thank again to the organizers for giving me an opportunity to talk about some of my knowledge. Thank you very much. So let's open for the questions.
If anybody has any question, they can put on a Slido and I can read it for Ganesh.
And don't forget to give a feedback. Okay. I mentioned the URL here, bit.ly/feedback UGE. If you click, it will redirect you to your same session. I mean the same portal through which you are listening to this video. So if you please give your valuable feedback. Okay.
Hey Ganesh, yeah, I don't see any question in the room.
Yeah. Thank you very much, Shashi, for moderating the session. And thank you very much, all the viewers who spend your time out here. So have a very nice conference rest of the day ahead for you.
No, thank you. Thanks all.
Yeah. Thank you. Bye.